Astronomers have been looking out into space for a very long time. Some of the things that are happening out there are mysteries. Others have shown their true colors to curious observers. One phenomenon that astronomers have discovered and proven is the movement of bodies in space. They know that the paths of the objects moving in space are shaped like one of the four conic sections, or shapes made from a plane intersecting the double cone: the circle, the parabola, the ellipse, and the hyperbola. Conic sections have evolved into popular ways to describe motion, light, and other natural occurrences in the physical world. We begin our study of conic sections with the circle. You'll remember a locus is a set of points that satisfy a given condition. So a circle is the locus of all points in a plane at a given distance from a fixed point on the plane called the center. The distance from the center to any point on the circle is called the radius of the circle. In this figure, the center of the circle is at the origin. By drawing a perpendicular from any point xy on the circle, but not on the axis, you form a right triangle. The Pythagorean theorem can be used to write an equation that describes every point on a circle whose center is at the origin. This gives us the standard form for an equation of a circle whose center is at the origin, or r squared equals x squared plus y squared. But what about circles whose centers aren't at the origin? Suppose that a point HK is the center of the circle, and xy is any point on the circle, and r is the radius. You can use the distance formula to write an equation for the circle. Using the distance formula, we get what's called the standard form for the equation of a circle, or r squared equals x minus h squared plus y minus k squared, which we're going to refer to as the standard form for the equation of a circle whose radius is r and whose center is at the point hk. With these tools in hand, we're ready to handle a question you might face. For instance, write the standard form for the equation of a circle whose center is at the point -3, -5, and whose radius is 4. I'll begin by writing the standard form. Then I'm going to write it again, but I'm going to leave a couple of blanks where I'm going to fill in some information. The point center is -3, -5. Careful of your minus and negatives. So our equation is going to come out to be x plus 3 squared plus y plus 5 squared equals 16. This is going to be our standard form for the equation of this circle. Another type of problem you need to be able to handle is if they give you the equation. For instance, write the following equation of a circle in standard form. Now we have to remember a little algebra. The technique I need you to remember is called completing the square. I'm going to take b, or the coefficient of x, and I'm going to divide it by 2 and square it. I'm going to add that to both sides of this equation. So I'm going to get x squared plus x plus 1 over 4 plus y squared equals 3/4 plus 1/4. Notice the first three terms, though, I can rewrite them now, and I've completed the square. It's x plus 1/2 squared. Now the y I didn't have to do anything with. Y squared equals 1. I'm going to rewrite this in standard form with the minus and minus just so you can clearly see what the center is. So this is the equation of a circle whose center is at the point -1/2, 0, and whose radius is equal to 1. And this is going to be the standard form for the equation of this circle. One more problem that you might run into with equations is if the coefficients of x squared and y squared aren't 1. And that has to be true in a circle. If they're not, we just have to take care of it. In this problem, I divide everybody by 3, put the 9 over the other side. There's the standard form for a circle whose center is at the origin and whose radius is 3. I rewrote it with the standard form equation. I'll give up that habit soon, but I want it clear to you. So the center here is 0, 0, and the radius is 3. The last problem that we're going to deal with today, we need to find a circle who goes through these 3 points, and you know how to use the standard form for the equation of a circle. But I also need you to know how to use another tool, and that is the general form of the equation of a circle, which we could rewrite the standard form algebraically and get the general form. But I think it's going to be a little easier if you just see how it's used. So here we go. Write the standard form of the equation of the circle that passes through the points 1, 3, 5, 5, and 5, 3. Now, you know that any 2 points in a coordinate plane determine a line. It follows then that any 3 non-collinear points in the coordinate plane determine a circle. The equation of a circle passing through 3 such points can be found by substituting the coordinates of each point into the general form of the equation. This will produce a system of 3 equations and 3 variables, d, e, and f. And by solving the system of equations, which we've done, the general form of the equation of the circle that passes through those 3 points can be found. Here I've written the general form, and for the point 1, 3, I just substitute in 1 for x and 3 for y. And when it all gets simplified, this will be d plus 3e plus f equals 0. Now, I'm going to do the same exact thing. So this is a little long, but it's repetitive. I'm going to do the same exact thing for the point 5, 5. You might want to jot down that equation. You see d plus 3e plus f equals a negative 10. I'm going to put 5 squared plus 5 squared. I'm going to put 5 and 5 in for x and y. I'm going to simplify the general form a little bit, and I'm going to come out with another equation I need you to jot down. 5d plus 5e plus f equals negative 50. The same thing now for the last point, 5, 3. Again, long problem, very repetitive, so I hope it's not difficult. I put 5 in for x and 3 in for y. And tighten that up a little bit, and I get 5d plus 5e plus f equals a negative 34. I'm going to take those 3 equations now and solve them just exactly the way we have been solving them using matrix algebra. First, I'm going to make up a matrix made up of the coefficients of those 3 equations. So the first one was 1, 3, 1 equals a negative 10. The next one was 5, 5, 1, negative 50. And the third one was 5, 3, 1, negative 34. And that's going to form what's called an augmented matrix. All review. I'm going to take out my calculator. Now I'm going to do this step by step, even if you don't have a calculator at home. But you know how to do this part. I'm going to go to matrix. I'm going to create a matrix. Let's see, this thing's going to have 4 rows. Or 3 rows rather, and 4 columns. And I'm just going to plug in those numbers that you just saw. Now at this point you could just say enter and then recall the answer, but I like to store them in a variable like a. And then I'm going to ask for a reduced row echelon form of this matrix, matrix A, and I'm going to get my solution, negative 6, negative 8, and 20. So I go back to my work and I find that D equals a negative 6, E equals a negative 8, and F equals 20. So the general form for the equation of this circle would be x squared plus y squared minus 6x minus 8y plus 20 equals 0. If I had to write that in standard form, let's see, I gather my x terms together and my y terms together. And I add my b terms divided by 2 squared to both sides. So the negative 6 over 2 squared is 9. The negative 8 over 2 is 16. So the first three terms become x minus 3 squared. The second three terms become y minus 4 squared. And tightening this up, I get positive 5. So if I rewrite this now, if I'm going to read this, remember it's minus the points. The center of this circle is at 3, 4. And the radius is not 5, but the square root of 5. And that's about all you need to know right now about circles. Here endeth the lesson. Thank you for your time and attention.